Hi, calculus. Well, I should be back in tomorrow, it looks like, I hope, but I wanted to just do a quick little mini lecture on that problem I gave you yesterday. I want to look at derivatives of inverse functions. In particular, the four important ones are the derivatives of natural log x, arcsine x, arccosine x, arctangent x. We already know natural log x. I gave you arcsine x for homework. I'm going to go over that. I want to do natural log again, though, because what you do with natural log is very similar to what you do with arcsine x to determine its derivative. So let's review how we get the derivative of natural log. And just to give you a warning, the test, which is coming next week, Thursday, you are responsible for knowing all four of these derivations. I could ask you for any of them. So let's see how we got the derivative of natural log x. What we did is we wrote y is natural log x. Then we said, okay, well, this is an inverse function. This means x is e to the y. And then I took ddx of both sides, derivative with respect to x of both sides. So there I've done it. The left side is 1. The right side we have to use a chain rule. The derivative of e to the something is e to the something. And then we have to multiply by the derivative of the inside. The derivative is some mystery function of y. It's not a mystery, it's natural log, but we're pretending we don't know that. So we get e to the y times the derivative of y with respect to x. And this, of course, means dy dx is 1 over e to the y. But this is no good. I want a formula with x's in it, not y. So then I look back up and say, wait a second. Looking back up here, e to the y is the same thing as x. And so therefore dy dx is 1 over x. And that's how we get our formula for the derivative of natural log x. Let's try the same thing for arcsine. So we're going to write y equal arcsine x, and then because it's an inverse function, this means x is equal to sine y. ddx both sides. The left side is equal to 1. The right side we have to use the chain rule. We get cosine y times dy dx. Solving for dy dx, I get dy dx is 1 over cosine y. All good. But I want a formula with x's, not with y's. Y is a different variable I introduced. And when I try the same thing, I have a bit of a problem. I say, okay, well, I'll look back up here, cosine y, but x is not cosine y, x is sine y. So I need a relationship between sine y and cosine y. And I told you yesterday we're going to use the Pythagorean identity. We remember sine squared y plus cosine squared y is 1. When I look up here, it's like, oh wait, sine y is the same as x. So when I come down here, I can say that means sine squared y is actually x squared. And then I'm going to solve this for cosine y. So I move the x squared over, plus or minus square root of 1 minus x squared is cosine y. So I put that back in over here. Replace cosine y with plus or minus square root 1 minus x squared, and there's my derivative. The derivative of arcsine x is this mess here, which is something you need to memorize. But there's a problem, and the problem is this plus or minus. It can't be both at the same time. I mean, the slope of the curve is either positive or negative at a point. It can't be both. We got to somehow deal with this plus or minus. And so let's look at the graph of sine and the graph of arcsine. So here's a graph of sine. And you know that sine doesn't have an inverse in general because it fails the so-called horizontal line test. A horizontal line can intersect the graph in more than one point, in a lot of different places. Horizontal lines can intersect multiple times over and over in here. So this is the same thing as saying that if I give you a y-coordinate, there's multiple x's that lead to it, that you need only one. So the trick for getting an inverse for sine y, for the sine function, is we restrict the domain. We say, okay, we're going to take the biggest domain we can that still passes the horizontal line test. We're going to go from here down to here. Oh, my arrow's not working well. And we're going to take that part of the curve, and we're going to throw all the rest of the values away, because if I try to include anything else, then I end up failing the horizontal line test. So this is angles that are in quadrant 1. This is from 0 to pi over 2, and angles that are in quadrant 4. This is from 0 to minus pi over 2. And when I restrict sine to just this piece, then just this blue part does have an inverse. That passes the horizontal line test. And the inverse would look something like that. So there's the graph of arcsine x. Notice this is horizontal, this is vertical, because you do that reflection to get the inverse graph. And notice here, now when we look at the graph, it's obvious. Oh, this is always going up. This is always increasing. And so therefore, my derivative of arcsine must be always positive. So when I look back at the, I wrote down these functions here. Over here we've got y equals sine x with the domain restriction, x is in minus pi over 2 to pi over 2, and then over here this is arcsine x. So when I look at the derivative with the plus or minus problem I had before, now I know that I always want it positive. And so that plus or minus is unnecessary. It's actually always positive. So we can drop that. And so we get the derivative of arcsine x is 1 over the square root of 1 minus x squared. And there's something wonderful, interesting going on here for the math geeks around us, which includes me. There's some deep connections going on here because this is all about trigonometry and circles and things like that. This is sine. So this is about circles and trig and stuff like that. When I look at the derivative on this side, the derivative is purely algebraic. There's no trigonometry or exponentials. This is all just algebra. It's a square root and squaring and adding and dividing. So there's some deep connections between trigonometry and algebra that this is beginning to reveal, that they're interconnected. Anyhow, enough waxing philosophical. You should memorize this formula, as well as the derivatives of arc, cosine, and arctangent, and I'm assigning those in addition to a practice test that Mary has for you to do for homework. So here's your entire homework assignment. The practice test showed d dx arc cosine x is minus 1 over 1 minus x squared, and d dx arctangent x is 1 over 1 plus x squared. And you're going to just follow the same pattern from the previous slide. Same idea is going to apply. Well, I hope to see you tomorrow. Enjoy, and have a good day.